So now for question number 2, we have name the following compounds. We have quite a bit of them, but our goal here is to name them. So the first one we have is Li2S. Okay. So what I like to do here is that I like to figure out if it's an ionic or a covalent compound. So for that, we have to look at our periodic table. So Li2S, that is a lithium and a sulfur. Okay, and lithium is a metal, and sulfur is a non-metal. So this is definitely an ionic compound. Okay, so that being said, we can now write at least it's going to be lithium sulfur. Okay, but we're not done quite yet. That is just what I like to do at the start. Okay, because whether it's an ionic or even a covalent compound, it's important that the ending gets changed. Okay, the last part, the suffix for sulfur gets dropped, and instead it will be sulfide. This is what we would have for Li2S. It would just be lithium sulfide. Okay. Now let's move on to the next one of what we have to name. We now have SnO2. I'll just list out all of them right now. Okay. K2O. Number 5 is Ba3N2. So SnO2. Same thing here. We gotta figure out if it's an ionic compound, because it does change the naming rules a little bit. Just like how with lithium sulfide, we didn't specify how many lithium we have. You don't typically or even ever see that for ionic compounds. We just say what they are. Okay? So Sn is, I believe it's a transition metal. If I can, nope. Sn is tin. So this is tin, and then we have oxygen. Okay, so now this one is a little bit tricky. It is one of the transition metals, or specifically a post-transition metals. So it actually has different, as they call, I guess, oxidation states. It could be, I know like one of them is like tin 2 and tin 4. But let's see, we're going to base it off the oxygen, okay? So the oxygen, similar to the sulfur, will end in oxide, but what we're trying to figure out is the tin part. Oxygen has 6 valence electrons, and to fill its octet, it usually just needs 2 more electrons. So we're dealing with O2 minus, okay? That is what oxygen likes to do. It's like one of the things you can base it off of if you want to be safe. But it's saying here we needed 2 of them in order to balance this tin out to make a net charge of 0. So if we need 2 O2 minus, we had a 4 minus charge. So tin had to be 4 plus. So this tells us actually what type of tin we're using. And we actually use the Greek letters here. No, the Roman letters. Yes, the Roman letters, sorry. And it'll be tin, and see it's 4, right? So it'll be tin, 4, oxide. That will be how you name this compound, okay? Because tin exactly can go through different states, and we need to specify which type of tin this is, okay? And now the same thing, we have rubidium bromide. Luckily for us, rubidium is just on the first column, so that means it's just going to be +1. And bromine, exactly, it's on the 17th column, so that's -1. So we really just have rubidium, and not bromine, but bromide again. See how the ides keep being there? Because that's one of the most important rules when it comes to naming these compounds. And rubidium. Hopefully I spelled it right. Yes, I did. And now K2O. Same thing here. We have potassium, which is 1 plus, and oxygen, as we saw, was 2 minus, and it just balances out. We can just say potassium oxide. Okay. And now for the last one, we have Ba3N2. Lucky for us, exactly, it's a face value again. We have barium, which is a metal, and nitrogen, which is a non-metal. And nitrogen does have -3 because it needs 3 more electrons to fill its valence shell, and barium does have +2 because it needs to get rid of 2 to have it's close to its octet. So with that, that's how we got the 3 and the 2 here, because we need 3 bariums, 2 nitrogens, so each one will be +6 now and -6 to have a net charge of 0. But we can just call this barium instead of it being nitrogen, we drop the ogen part and it's nitride. Okay, so all of these technically was a metal versus a non-metal. Okay, the only tricky one was tin, because post-transition or even transition metals do function a little bit differently when it comes to naming rules. Okay, so with that being said, let's go back to this and we'll see how we did. So lithium sulfide, they do say this one is just tin oxide. Let me check the periodic table just to see. I can see how it is just tin oxide. That one is a little bit tricky. Rubidium bromide is correct. Potassium oxide and barium nitride. So with this, just because I want to make sure that it is 100%, the tin oxide may just be the name because it's on the 14th column, to where tin is always 4+. I'm not sure if I've seen tin 2+, but let's see if we can find that. Tin 4. So that is the name that is given. This is one of the tricky parts about the naming, is sometimes there are more common names and there are more specific names. But let me see if there is even a tin. Let's see what tin 2 iodide looks like. So there are different states for tin. So technically the most correct answer would be that. The only issue with this, which is what I do recognize, is that on the periodic table, just like how you don't really specify for carbon, tin doesn't really get specified for. I mean, tin, with that logic, because it's on the 14th column, shouldn't really get specified for either. But that's why I do stress the whole transition metal. Tin is technically a transition metal. Well, as you can see here with the coloring, it's known as a post-transition metals. And those things do pose a chance of having different oxidation states or different charges of what ions they could form. So in this case, although tin oxide is a possible answer, to avoid confusion on which type it would be, I would specify still that it's tin 4 oxide, just because we always want to be as specific as possible when it comes to these transition metals. Okay, that's the only thing I would say here. So this is still correct, but I would have tin 4 oxide to be more specific. Okay, so yes,